In this chapter, we're going to be discussing rotoscoping. And rotoscoping is an actually quite old process from the origins of film. It actually started as an animation technique where an image, projected film image would be projected on a piece of paper and an animator would trace over it. And it was used for creating initially character animation. It wasn't until later that it was used for the purpose of traveling mats for visual effects integration. And that's primarily what we use rotoscoping for today, although there are still some examples of rotoscoping used for animation. But that is what rotoscoping is. It is the tracing of objects to isolate them from their backgrounds. So in this example that we're primarily going to be looking at, we have our two American astronauts from our short Over the Moon, and they were shot in this pretty simple set, which is actually quite wonderful though because it allows for interactive lighting. The light is bouncing off of this volume very realistically, and it gives them something to interact with when they're acting. The only problem though, as you can see, we don't have any green screen. We don't have any clear way to separate them from this background. And we do want a more impressive background, a more capsule-looking background with controls and things. So we've actually generated in a CG program, we've made a very nice detailed program to match most of the geometry of our set. And we need to somehow integrate just these characters into this background. So that's really going to be our challenge for today. But let's start with a simpler example. Usually when we're rotoscoping, it'll be over a range of frames, and it can actually be quite a labor-intensive process. But this first example will be a little simpler. It'll be a single frame. We could show how rotoscoping can be used for simple image manipulation or photo manipulation. So here we have two versions of our background. We have a version 3 and a version 4. So this is a newer render. And you can see the main difference is that there was some additional detail added up in the roof area. The problem is that it created a change in the lighting below the surface where there wasn't really much change in geometry. And so one of the comments was that the lighting looked better in the version 3, which didn't have the roof detail, but the roof looks better in version 4, but we don't like the lighting. So we really want to combine pieces of these two renders into one. And once again, this is where Nuke really becomes powerful, because instead of going back to our 3D package and trying to figure out a way to render this additional detail up here without changing the lighting, first of all, it'd take a lot of time for the 3D artist, but then it would take time to render as well. Here we can just hop in and make changes right away. So how can we combine these two images? Well, we need to merge them together in such a way that only the roof area from version 4 is combined with the wall detail from version 3. And to do that, we're going to need some sort of alpha channel or a mat so that we isolate the roof from the walls. And we're going to use a rotonode for that. So once again, here is a preview of what we're going to be accomplishing. You can see we have the lighting detail has remained the same in the bottom of the image, but the roof has been added in from our version 4. So let's go into detail how we did this. I'm actually going to start from some fresh renodes. So here's where we need the roof detail, and here's where we need the wall detail. And the first thing we need to do is we know they're going to have to be combined in some way. So I'm going to use a node called the KeyMix node to do that. And the power of the KeyMix node is that in addition to standard A and B inputs, it also has a mask input. So this key mix will still operate in a similar way to the merge node. A will be over B, except in the areas that are masked out. And what we're going to connect to this mask input is a roto node. So my roto node is found in my draw toolbox. You can see I have a roto node and actually another node called a roto paint node. We'll talk about that one in the next chapter, but suffice to say you can also do roto amongst other things with this node. But we're really only need to do roto, so we'll use a simple roto node. You can see the hotkey for that is the O key. I would assume because roto has a lot of O's in it. And the roto node, when we first add one to our node graph and view its properties in Properties Bin, a few things happen. First of all, we get some new tools showing up inside of our viewer. This is the first time we've seen something like this. So I'll go ahead and close the Properties Bin. You'll see those things go away. But as soon as I open it again, those tools appear. And even if my a different property is open and not focused, these overlays and the roto splines will always be visible as long as it is open in your Properties Bin. But we want to go ahead and edit this roto node for now. And what we know is that we want to separate the roof from the walls. So a good place, a good dividing line would be this metal strip right here. And then this area is mostly the same between the two images, so we can just cut in between them. So let's go ahead and begin our roto. Now, as I mentioned, the tools for the roto node are all found in the viewer at this point. There's three main tools for creating roto splines and editing roto splines. And you notice I'm calling them splines because that's primarily what they're based on. There are a few tools which are just straight lines, such as the rectangle tool or the cusped Bezier, but the rest of these are actually what are known as splines, mathematical splines, such as the Bezier spline or a B-spline. Even the ellipse will actually, and the cusp spline at some point will have some spline-like properties. And these are, well, I guess the easiest way is to demonstrate a couple of them. So let's start with the Bezier. And with the Bezier spline selected, I can simply click and drag in my viewer to create a new spline. If I click and don't let go of the mouse and drag, then I'm actually now modifying the Bezier handles. The Bezier handles define how curved the line is from this point. So I'll let go and then click another point, and you can see now a little more clearly what those Bezier handles are doing. It affects how curved the line as it heads towards the point is. So in this way I can create a circular shape, and then when I click on my first created point, I close the spline. So now I have a closed spline. You can see in my Properties Bin that a new Bezier shape has been created. Think of this as a Layers property window, where we can see every roto spline that we've created and set some of the options per spline. You can also see there's lots of options for the roto node, but we're not going to be going all over them all today. But let's continue with our tools first. Now that we have a spline created, we have some additional tools we can use. These two menus come into play. First one is our pen tool, and our pen tool is used for, as you can see, adding, removing, cusping, smoothing, modifying essentially the points on an existing spline. So as a simple example, with the add point tool, I can click somewhere on the existing roto spline and I create a new point. If I don't like those points, I can remove the points. And if I want to smooth out the points, I could just click on them and smooth them out. Here you'll see for the first time what cusping means. Cusping simply means that the points come to a sharp angle. So with the cusp pen tool selected, I can double click on a point not working for some reason. Well, essentially, the pen tool allows me to modify the spline in a bunch of ways. So let's get it back to how it was. And then let's talk about the next tool, which is the selection tool. Selection tool can be accessed with the hotkey Q. And that's going to allow me to select a spline, or, for example, select points. And the selection tool is useful for moving existing points or changing handles. When you're working with Bezier points, it becomes really important to get used to the modifying tangents quickly. And moving points is the main way that we're going to be animating these splines in the future. So for a lot of what we do, we are using the select point tool. So keep in mind, clicking on the point itself will move the point. Clicking on one of the handles will modify that side of the handle. And then clicking on one of the handles and holding the Shift key will modify both handles by the same amount. So in this way I can round out my circular shape. In fact, I can make it almost a rectangle with rounded corners if I make my tangents long enough. There's other tools in here, for example, selecting all points. And a lot of my hotkeys will work as I would expect them, such as Control A for selecting all points. And at this point I now have a transform box that allows me to move the entire shape as a whole, allows me to scale the shape as a whole, and allows me to rotate. So very handy if you have a shape that's moving around as a single piece. Okay, so that is a Bezier spline, and so once again I want to iterate the key concept of a Bezier spline is these tangents. Okay, so let's go ahead and get rid of this Bezier spline. Let's try another spline. So we have next the cusp Bezier. You can see once again, cusp in this case means we have simply tangent points that do not have handles. They do not have curvature to them. If we're interested in converting those to non-cusped points, we can use our pen tool, and then we're back to a standard Bezier. But the cusped Bezier is wonderful for just creating simple polygons and geometric shapes. Great for garbage mats, or also known as quick masks for removing things from your green screen footage. The last type is called a B-spline, and a B-spline is separate from the Bezier in that it does not have tangents. Instead, you can see that the B-spline actually acts as a lattice work for the actual rotospline inside. So this first red line is actually our B-spline lattice, and the inner rounded shape is actually our rotospline itself. So this is a handy way to do roto because it allows us to simply lay down points and allow the lattice to smooth out the shape for us. The Bezier splines can be a little tougher to animate, especially. Animation of Bezier handles can be a nightmare, and if you don't have a simple enough shape, then it can be near impossible. But once you get good with them, Bezier actually allows you a lot more control. The B-spline, however, is great for beginners because it allows you to quickly roughen the shape. You'll end up using more points because you have less control over the actual roto shape because of the way the lattice works. But once again, the animation, you don't have to animate tangents, and that can be a huge lifesaver. The remaining roto shapes are just if you need simple shapes and you don't need a custom shape drawn with points. So an ellipse will be an oval or a circle if you hold down the shift key. This is great for drawing perfect circles, or if you have an object that you know the center of it, you can click and drag in the center, and hold the control key, and then your circle will form from that central point where you clicked. The shift key will constrain you to a circle, or you can let go of the shift key and then make an oval. Once again, these are, after they're created, they are simple. These are simple Bezier curves, and they can be modified after the fact. We also have a rectangle. Once again, shift to constrain to a square, control to expand from the center. And once again, this is great for making quick garbage mats, separating an element from contamination on your green screen, perhaps. So that covers most of our options in our Roto toolbox. So once again, now we have a new toolbar separate from our node toolbar, and this will only be visible as long as we have our Roto properties open in the bin. We'll get into these elements when we start doing some animation, but so let's go ahead and start with our first example though. So I need to create a Roto shape that cuts at this break in the image so that I can separate what is visible up here versus what's visible down here. So these are perfectly straight lines. This is the perfect job for the cusped Bezier. Now the thing with Roto is Roto can extend off of the edge of your image. And that's what we want to do in this case, because we want to make sure we get everything up at the top part of this image. So I'm going to start my first point off the top of the image, and I'll create my next point at this change in angle, then here, and then this wall is the same in the two images, so I'm going to go ahead and extend into it, and then off the top of the screen, and then close my Roto spline by clicking on my first point. Now, what have I done exactly here? Let me connect my viewer to this point, and you can see there's no image coming into this, so it's just going to be a black screen, except the Roto node is generating one important thing, which is the alpha channel. And so if I hit my A key, I can see that I have generated an alpha channel. Remember, in my alpha channel, everything that's white will be opaque, everything that is black will be transparent. And that's really all I need this to be. But if I look at it in the RGB view, it's going to just look like a black screen. So I need to connect this into something where that alpha channel can be used, and I'm going to use that mask input for my key mix. So now let's look at our new view. Now remember that our alpha channel is still present, and so with the key mix node selected, I can hit the A key, and you can see I'm not having an effect on this image. Everything that was white in my alpha channel is going to be white in my key mix. So I actually need to invert. Well, I could do two things. I could switch my A and my B input, which actually would be pretty easy, but I'm going to invert my roto just to prove a point. So this is what our alpha channel looks like coming out of the roto node. But here in my rotospline options, you can see one of the columns is inversion. So if I click that, now that spline will be inverted. So now this portion of the image will be transparent and this portion will be opaque. So if we look at our key mix now, this looks more correct. We're taking our A input, which is going to be under because it's A, or sorry, over because it's A. And anything that is white in our mask will show through. So that means what was white in our roto was down here. So that means everything in our version 3, which is down here, will be shown through. Here we have our roof, and everything that was black is what's going to show through to here. So looking at our key mix node, we now have the roof of our version 4 and the walls of our version 3. So I can do a wipe between these two. And you can see it's a subtle difference, but the roof is identical because we've mixed it in, but our lighting is coming from our version 3 because we've masked that in. When we're looking at this image right now, we want to make sure the areas I'm looking at are right near our roto line. And remember, that's still visible because it's open in the properties. Anything that looks like it would be different between the two, maybe this area right here, well, it looks like we're safe. These are the things we would want to be really careful of because they would create some sort of visual distinction between these two areas. So let's go ahead and close our roto node just so that line goes away completely. Turn off our wipe. And you can actually see we are getting a bit of a line right there. In fact, we're getting a bit of a line through the metallic part of our separation too. So we could move that right to the edge where we could hide our alpha split a little better. But then there's one other thing I can do. So first of all, let's go ahead and edit this a little bit. So I'm going to double click my roto node to open its properties bin again, and now with the select tool option selected, I can modify that. And you can see now, as I move it, I'm seeing the changes that effect I'm having on the image. So let's go ahead and make this connecting a little more in a subtle way. I'm going to use the pen tool with the add point tool. I'm just going to try to hide these points a little better. Go ahead and try to cusp this point again. That worked at that time. Not that time though. So what I'm trying to do is just hide this roto line a little better. Inside of my image. Alright, I think that's going to be a lot better. Could move these once again just to the edge of our breakpoint there. Now you can really start to see how that's going to work a lot better. The last thing I'm going to do, though, to make sure this transition is completely invisible, is I'm going to make it not such a hard transition. Right now, for example, right here, it's a little bit of a hard transition. But since we're dealing with lots of nice soft lights, this is the perfect opportunity, is the feathering feature. So feathering is a feature of rotosplines that allows you to affect the alpha channel. Because right now we go from black to white very abruptly. Feathering will allow me to create a gradient between that change. So with the correct spline selected, remember I can have multiple splines, so I can set my feather per spline. Here I will select it and adjust the feather knob. And you can see as I bring that up, it creates a gradient. Instead of a hard fall off. You can see if I give it a negative value, that the gradient or the feather goes inside of the shape. Or I guess in this case, yeah, inside the shape, and if I have a positive gradient, it goes outside the shape. So we'll go ahead and let it fall outside the shape. And I'm giving it a pretty strong value of about 24 because I really want to soften that transition. And now if I look back at my image, you can see that transition. It's very difficult to see. Looks good. And I think we can call this composite done. So this is what we started with. Version 3, no roof detail, but nice lighting below. Version 4, roof detail, but we don't like the lighting below anymore. And here is our mix. All right, so that's the first example we're going to use for the roto node. Single frame, no animation required, very simple example. But the next thing we need to do is we need to integrate our actors into this shot. Now we have no automated way to remove them from this set. Well, we just want them and their props, and we don't want any of this set because we're going to replace it with this set. So we can use rotoscoping in the same way to separate these actors from the background. I'm going to go ahead and open up a script that I've already been working on. You can see this is a script just for doing rotoscoping. And scripts for doing rotoscoping are pretty common because you might be, for example, sharing the workload of creating roto between multiple artists. So you would have different artists working at their own stations on the same shot, but each one is doing rotoscoping for a different part of the image, for example. And then what you end up with is a few nuke files, which you can then combine inside of a master comp, our master composite script. So we're going to do an example of that today. So here is the nuke script for doing the rotoscoping on this foreground character. So as you can see, all the rotoscoping has actually been completed, which is great. You definitely don't want to watch me doing rotoscoping today, but let's go over the script and see what was done. So if we start at the top of our composite, we have our original footage. As you can see, this is being loaded in as an EXR file. When you're doing rotoscoping, it is important that you work on footage as close to the original as possible. Your rotosplines are going to be placed with sub-pixel accuracy, and you're creating alpha channels that you want to remain that accurate. However, rotoscoping is also a very frame-to-frame laborious task. You're going to be loading your clip many times, going frame to frame, and you want your viewer to update very quickly. So full HD EXR files are going to be a bit slow. So this is a wonderful time to be working with a proxy. Remember, this is separate from our down-res options where we can set our viewer to a down-res resolution and then our playback will be much faster. The problem is, obviously, we cannot rotoscope this. So this is not this is not a good way to speed up our playback speed. We want to use a proxy. So I actually created a proxy frame sequence for this shot. This could be a QuickTime movie. This could be a series of JPEGs. That's exactly what I did. So this is the exact same shot created with simply with a series of JPEGs. Pausing here for a moment. No need to write this down. Well, if your proxy and your EXR have different frame ranges, then apparently the start at frame range doesn't work. So I'm not going to be able to use proxies as discussed, but the points I made are still valid. So for now, we'll be viewing the EXR. Alright, so with our proxy mode enabled, our frames are going to load a lot faster and we can really get into the roto. Now, rotoscoping for a human character is some of the hardest rotoscoping you can actually do. And that's simply because they're very organic shapes, they're very stretchy, there's lots of folds, especially a human being wearing clothes or with hair. In this case, we could be thankful that they're wearing caps at the very least so we don't have to deal with their hair. But there still is very amorphous shapes going on. As he brings his hand over to bring up the sights on the gun, we deal with the problem of motion blur. When we have semi-transparent pixels, how do we create an alpha channel for that that can be composited nicely? The important thing when tackling something like this, though, is to tackle it piece by piece. In the last example, we only had to make one rotospline for the roofline. And here you could make one rotospline for the gun and him and all in one piece. But the moment you go to a next frame where you have to create some animation, it becomes extremely difficult to animate that giant spline so that it makes sense. It is much easier when rotoscoping to separate your rotosplines into many smaller pieces. And then each one of those smaller pieces, instead of being modified point by point, can then be translated as a whole, or even connected with a tracker node so that you can track simple movements. So that's exactly what we've done in this example. We have, we'll actually start from the bottom. We have rotoscoping for the head. We have, let's go ahead and look at our final output. We have rotoscoping for our head. We have rotoscoping for our body. You can see how these pieces are all broken up into small chunks. We have rotoscoping for the gun. Here, the front of the barrel, and then the sights and the pieces in the back. And we have rotoscoping for the screen right. That's what SR stands for in this case. It's important to start referring to things as they appear on the screen, because to call this the right arm roto would cause problems, because this is actually the actor's left hand. So we use the abbreviation SR and SL for screen left, screen right. So his arm in this case is on the screen right, so it is the screen right arm roto. And we made this its own thing separate from the body because, for example, when he brings his hand up to modify the gun sights, you can see that it's many complicated pieces. But you can see that it becomes important to separate out your roto shapes to make it easier to animate. And it isn't too difficult to combine them back together. This particular rotonode is an example of a rotonode that has multiple splines within a single node. But then we have pieces that are single splines on a node, and we combine them back in using merge nodes. All we care about with these splines is that the alpha channel is being combined. And an easy way to combine roto splines is with a merge node set to max. Max will simply take the lightest of the 2 pixels in the comparison of the 2 inputs, and so that means white will always be the higher value and will always come in to a black alpha channel. So each rotonode we add in with a merge set to max will just get added into the alpha channel. So you can see each one of our rotonodes gets merged in with a max operation. So let's dig in a little bit into one of our rotonodes. I'm going to go ahead and set my properties bin to only show me one node at a time, just so I don't get too many rotosplines showing up on the screen. And let's use the example of our actor's hand. There's a couple of things that we haven't seen before that I'm going to talk about at this point. First of all, these splines are animated. I can select them one by one and look at them on a frame-by-frame basis, but as I move to the next frame, they move. And I can tell that they're animated simply by scrubbing through the timeline, but I can also tell they're animated by the color blue. The color blue becomes really important for determining if there's animation. I can see it in 2 key places here. First, I can see it in my timeline. As I select different splines, I can see this blue line in the timeline change. And that blue line indicates frames on which there exists keyframe animation. Now, we talked about what keyframe animation is in our fundamentals. So this blue line simply defines where those keyframes are, where we have set a keyframe for this spline. We can also see blue in our knob windows, in our properties bin. And this indicates that that is the property that is being keyframed. So in this case, on frame 1070, we see that there is a keyframe for the spline opacity. And there's also a keyframe for the spline itself. That would be the points on the spline. On a different frame, we see that there's a keyframe for the spline itself, the points, but there is not a keyframe for opacity because it is not the same bright blue. There is animation somewhere in this timeline for this value, but not on this particular frame. So this simply allows us to see when there is animation for these frames. But what is an easier way of visualizing these keyframes? Well, now we get to talk about the curve editor and the dope sheet. The curve editor and the dope sheet are both used for visualizing keyframe animation in two different ways. The curve editor allows us to see animation curves for knob properties. In this case, the curve editor is only showing us keyframes for opacity. And you can see opacity is very simple animation. In this case, it's either 0 or 1. And that's why this animation curve is not so much a smooth curve as it is a hard straight line, on and then off. If we wanted to create more smooth changes in our opacity, we can move these points on the curve, and then once again we start seeing things like Bezier curves that we see inside our rotospline, and we can adjust how smoothly the transition is over time of this opacity setting. So now instead of just being 0 or 1, we can have values in between that are animated or in between for us automatically using the curve editor. So this is a very useful feature for animating keyframes or values over time. Let's go ahead and undo that. You can see I have different keyframes on depending on which spline I have selected. So that's the curve editor. We're going to get more into this when we modify some other properties. One of the more useful animation views for rotoscoping, though, is the dope sheet. So the dope sheet has a very similar function to the curve editor. However, the difference is it only allows us to see keyframes. The dope sheet is simply for looking at keyframes and adjusting their timing. Whereas the curve editor is used for modifying values over time, the dope sheet is just for modifying a keyframe's position in time. And you can see the other thing that is different about the dope sheet is it actually shows the keyframes for the curve keyframes. Remember, we have a Bezier curve or Bezier spline selected. This refers to the keyframe for that shape. And each one of these points represents a keyframe. I'm simply zooming out the same way that I've been zooming out of my viewer in my node graph using my mouse wheel, or I can hit the Alt key to pan. So if I zoom into this area where there's a lot of animation going as he lifts his arm up, I can see right here where my blue animation frames exist on the timeline. These are all of those keyframes for the changing shape. You can see at the beginning and the end of the shape coming into view, there is also keyframes for opacity. And similarly to what we saw in the curve editor, it's just going from one frame, the opacity being 0 or invisible, to the next frame with a value being 1, where it is now visible. And we're using this technique simply to hide the effect of the Bezier spline when it's no longer needed. From before this frame, this Bezier spline, or the object that it's being used to rotoscope, is not visible. It's behind the barrel of the gun, so we don't need it to be visible. And then after this last keyframe, it is also invisible. So it's only needed when he lifts his arm over the top of the gun barrel. If I wanted to change that, I could simply drag a box around those keyframes and move them somewhere else. And now the opacity doesn't change to 0 until a later frame. Obviously, that's not correct though, so let's undo that. So the dope sheet, very useful for changing the timing of your keyframes. Let's go back to our node graph. And let's talk about creating this animation. So far with Curve Editor and the dope sheet, this is really more for editing. But if I want to create animation, for example, I may want to recreate some of the roto I've already done. Let's go ahead and use this gun barrel roto as an example. Very simple shape. So let's pretend like this isn't here. You can see in our final output that where the gun barrel was before, the alpha channel has not been generated, so it's not visible. Let's recreate it though. When I'm doing rotoscoping, I'm going to want to make sure I'm looking at my full image so I can see what I'm tracing over. I'm going to go ahead and add a roto node with the O key. Oops. Add it to the side here. And connect that in to this merge node. Let's go ahead and create a B-spline in this case. And we want to create the B-spline just for the front of this barrel. So I should be careful as to what frame I'm on. For example, if I started the rotoscoping on this frame when the gun is off the edge of the screen, that wouldn't be smart because I wouldn't know what the full shape of the object looks like. It's much better to start your first roto keyframe on a frame where most of the object is visible. So since I'm using a B-spline, which will be a lattice for my actual rotospline, I'm going to start the barrel off the back of before the sight. I'll create a couple of points. I know that because of the depth of field blur, this barrel actually has a bit of a bend to it. So I'm going to create a point just in the middle, even though it's mostly straight. And then I'll create 2 points on the outside. And close my spline. After I've created the spline, I might need to go in and tweak it just a little bit. And there you go. If I look at my final results, my gun barrel is back in the shot. However, the moment I go to a new frame, I can see that my rotospline does not move and the illusion is lost. We need to be able to animate this spline so that it follows the motion of the actual shot. So I'm going to go back to my frame where I have a keyframe. The moment I created the spline, the roto node automatically created a keyframe for me. I can see that in the dope sheet. There are my keyframes. So let's continue on with some simple animation. I'm actually going to use just a little, there's a little bit of bobble in the gun as he moves around. So if I want to, I can find another point in the clip, select all the points, and shift them so that they are correctly lined up with the image. Now when I did that, when I modified the keyframes, a couple of things happened. Well, one thing happened mainly, is that another keyframe for the spline shape was created. You can see the blue line on the timeline, and once again our spline key is set. This is done because the auto key option is turned on in the Roto toolbar. What this means is anytime I modify the points or the properties of that roto spline, it will create a new keyframe for me. If I don't want that to happen, if I want to, for example, use the manual keyframe creation button, then I should turn that off. And now when I move the node around, I can't actually move it around until I add a keyframe. With a keyframe added, with the keyframe added, now I can move the image around and my keyframe is updated. 99% of the time you're going to want to leave auto key on. It's a very useful feature. It's there for a reason. In fact, this keyframe is terrible. I don't want it, so I'm going to remove the keyframe using the delete current keyframe button. I'll go back to my existing keyframe. I'll turn that back on. I have my add and remove keyframe buttons up atop as well if I prefer to use those. So what's happened between these two keyframes? I can see them in the dope sheet as well. Between these two keyframes, Nuke has filled in a little bit of animation. This is a process known as in-betweening. So from this keyframe that I created to this keyframe I created, Nuke has created this additional movement. And you can see it does a pretty good job of interpolating between those two extremes. Setting keyframes for Roto is all about finding the extremes in the motion. You want to be setting keyframes for the spline shape at every extreme of the motion. The less keyframes you add, the better your rotoscope is going to look. If you have keyframes on every single frame, which might be necessary for some very complex shapes such as this hand. This hand is moving so much from frame to frame and changing shape so extremely that you'll end up having keyframes every single frame, as you can see. But for objects like our gun barrel, this does not move too much, and we can do something much simpler, such as setting keyframes every, in this case, almost 10 frames. But anywhere where there's small jerky motion, we would have to add maybe 2 keyframes in a row. So that's the basics of adding keyframes. So you can see how this process would continue. You would simply find the next extreme in the motion and set a key, make a slight motion change. Maybe I can use the rotation. And slowly we'll get all of our rotoscoping done this way. The other way to do it, though, introduces a little bit of automation into the process, and that is to link our rotospline to a tracker. Now, we are not going to be talking about tracking for a couple more chapters, but if you've already covered the tracking section, then you understand how we generated this tracker. And this tracker simply takes elements of the image and figures out where they are as they move. So for example, we've created a tracker that tracks just this corner between the gun sight and the gun barrel. And using that, we've actually linked the roto node for the gun barrel to that tracker, and now we are transforming the roto to follow the gun movement. So we have the same thing. You can see we have very few keyframes throughout the image, but we're still getting a lot of nice secondary motion of fine pixel tracking from our tracker node. So there's lots of uses for the tracker, and this is one of the big ones. The tracker node, the planar tracker node, and even a camera solver, which allows us to do 3D tracking. All of these can be used with the roto node to finally place our spline over the top of a moving image. And this is ideal for shapes which do not change their shape. Any object which doesn't change shape and it simply changes position and perspective and size and rotation, those are the types of things we can use tracking for. So this is a pretty good example. Planar tracker probably would have been great for this. So this is the ultimate result of what we're looking for. I'm going to go ahead and actually, before I do that, I'm going to talk about two more things. I'm sorry. So in addition to tracking, our rotoscoping, there's a couple of other pieces of automation we can do. First of all, there's a couple of key moments in this sequence where the edge of our shape is not exactly clear. Let's look at this example here. This hand over the background. Because of the shutter angle on the camera, we're creating a lot of what is known as motion blur, as the hand is actually moving while the shutter of the camera is still open. So it's not a sharp, crisp edge like other parts of our image. We have instead something that is blurred. So how would we rotoscope something like this? Well, there's a couple of ways. First of all, one of the first things we could do is we could use the feather feature of the roto node. The feather feature is found with the selection tools. When we select any point using the Select All selection tool, we get an additional line that comes off of the point. I actually have motion blur turned on, so I'm going to turn that off just so we get a preview. So normally when we do a rotospline, we have a hard edge once again. It goes from white to black very crisply. We talked about using our feather feature, which is going to apply feather uniformly to all points. However, if we want to create a per spline feather, or per point feather, we can use the feather on a per point by clicking on that line that comes off of the point to create a second line, this time a dashed line. And the dashed line defines the transition of the feather, of the per point feather. I can have it inside the shape, or I can have it outside the shape. And you can see what's happening from our main roto line to our feather roto line. It is creating a gradient from our mask color to our outside mask color. And this allows us to create a transition of color that might match the motion blur. So here, as an example, this is where I would consider the core of the color to be, and this is where I would consider the edge of the blur to be. So this would be a good approximation of the motion blur. Of course, you can see the problem with this. This now requires us to do twice the amount of roto. We have to create an inner line and an outer line for all of our roto. This is going to give us very accurate results, but it's not going to make this job any easier. In fact, there's a much simpler way. If we have a spline that has animation, that has movement, either through a tracker or by animating with keyframes, then we can turn on a feature, an automation feature called motion blur inside the roto node. And just like the invert option, it is one of the columns in the roto node. And by clicking the motion blur button, show you that in the alpha channel. By clicking the motion blur button, I now have automated motion blur based on the direction that the individual points are moving. Now I can set additional options on how this motion blur is generated with the motion blur tab in the roto node. And here, for example, I can determine how much quality there exists in the motion blur. That's what the motion blur knob is for. You can see the lower the number closer to 0, the less fine-tuned the motion blur looks like. And as I bring it up, it starts to get higher in quality, but it also will be slower to process. In this case, at the level that we're zoomed in, it may look a little bit janky, but I found that a setting of 1.25 worked well. The shutter determines how much motion blur there is. This actually is the equivalent of our shutter on our camera that captured the scene. So with a smaller number, there will be less motion blur, which would be the case if we had a small shutter opening on our camera. And with a higher number, we'd have more motion blur, which would be the case on a camera with a long shutter setting. I'm going to look at my shot and just toggle between the alpha and the image, and I can see that it's going to be pretty short actually. Right about there. And then the last option is the shutter offset. Do I want the motion blur to be centered with forward and backwards motion, which is going to be the case 99% of the time? Do I want the motion blur to come in front of the motion? Do I want the motion blur to come behind the motion, lagging behind? Or do I want to set some custom offset? And here I can use the slider to determine where that motion blur exists. Like I said, centered, in this case misspelled, is going to be the correct way for this motion blur to look. Now I can set motion blur on a per shape basis, which is great because different roto artists are going to roto the original spline in different places. So allowing the ability to set the shutter and the quality settings on a per spline basis is really handy. However, if I want a setting that is going to be applied to all my splines, then I could use the global motion blur setting. And here, I set a value once, and all splines that are also checked to the global setting will inherit these values. That's what I'm going to use in this case. So now, anytime I turn on motion blur for another spline, you'll see that now that spline also receives the same amount of motion blur. So that's the motion blur setting. So we've turned on motion blur for a few key roto splines in this shape. But remember, we are simply generating an alpha channel. An alpha channel is similar to our red, green, and blue channels. It can be modified in other ways. So if for some reason you're not getting good results with feathering, or you don't want to do the work that's involved with doing per point feathering, or the motion blur is just acting completely nonsensically, then you can actually go in and modify alpha channels using standard tools set to the alpha channel. So here's our gun barrel, and as we know, the gun barrel is being affected by the depth of field of the camera. The front of the barrel is a little more blurry than the back end. So what I've done in this example is my roto is actually a solid color. I've used a dilate node set to the alpha channel to bring that shape in a little bit. So you can see the dilate node has brought in the alpha channel a little bit from there. And then I've used a blur node to blur that slightly. And then I merge it in with the rest of my rotosplines. So there are lots of ways to modify rotosplines, and having them separated out on a per object basis really allows you to customize them and make them the highest quality possible. By the time we're done with everything though, we end up with one big rotospline. And in this case, since I'm going to try to integrate this into a composite, I've also added a pre-multiply node so that the background is turned black and my matte edges are pre-multiplied against black. And this will allow me to integrate this element into our existing master composite. So let's go ahead and switch over to that now. So this is our background that we ended at. And here is our EXR sequence that we need to integrate, but we don't yet have any roto. Now we have two options here. From our separate roto nuke script, we could actually render out a PNG we could render out the alpha channel as an image sequence. So I've actually gone ahead and done that just to show you the way that is possible. So I have my rotomats, and I actually generated two different versions. I have one version that is our foreground character by himself, and another version that includes the background character. We'll go ahead and use the one that has both characters in it, and I'll say open. And the first thing you'll notice when we bring this image sequence in is that it is red, which is odd. Well, there's actually a reason this appears red. A rotomask is generating an alpha channel, which is a single channel worth of information, normally set in the alpha. The alpha is considered to be a fourth channel after red, green, and blue, but if you are creating an image file that only has one channel, Nuke will default to putting that channel in the red channel. So if I look at my channels for this matte, look at red, I can see my matte is in my red channel. If I look at green, it's all black. If I look at blue, it's all black. And if I look at alpha, there is no alpha. So the alpha channel has actually gone into the red channel. And that's fine, because I can use a shuffle copy node to bring this red channel in as my alpha channel for this. I want the red, green, blue from this, and I only want this as an alpha. In my shuffle copy node, my input of 1 will be my red, green, and blue, and the input 2, which is the matte, will be incoming as red, but will be going out as alpha. So now I have my red, green, and blue, and an alpha. This is exactly the type of thing that I need then to be able to merge into the rest of my composite. I could do simple A over B composite. One of the keys, I don't have a pre-multiplied image. And it looks like my matte export is a bit off as well. I know exactly where that is. Still a bit off. Oh, no, not offset. Start at. There we go. So that's one way to bring in my material. If you have a slower computer, or you're just finding your Roto script to be a little heavy, then this might be the ideal way to do it. This is the same as pre-composing, essentially. Instead of having a bunch of Roto nodes that we can edit after the fact, we have rendered out that compositing script. So this is now locked in. If we make any changes to our Roto, we need to re-export this element. But all the same, once it's done, we get pretty good results. So now we can place our actors into our CG environment. Obviously, there would be some color grading necessary. Refer to the color correction chapter for that. The other way to do this, though, is to actually just bring our entire Roto Nuke script into our master compositing script. So I'm going to go to File, Import Script. And I'm going to bring in the Roto NK file for this shot. And what this is going to do is actually bring in all of those nodes as they existed in my other Nuke script. So if I spent time organizing them and color coding them and making them look pretty like I did, then I have a nice final script that I can bring in. So here's my background, and here is my Roto. And once again, everything is still editable. So this is a wonderful way if you're having, once again, separate artists doing rotoscoping, you can bring them all together in one script and still be able to do edits after you create your final composite. So let's connect that instead, and you can see we get the same results. In this case, I didn't do the Roto for the background guy, so we don't see him anymore, but exact same results. If I want to be able to do any kind of color matching, I want to make sure that I add my grade node before my pre-multiplication, and then I can begin to integrate these two shots together. So that is an introduction to the Roto node. In the next chapter, we're going to be talking about a similar tool called the Roto Paint node, which, in addition to being able to do Roto, it can also do frame-by-frame paint, which is useful for all sorts of fixes and additions to your images. See you next chapter.